Hello there. Thank you for joining us on Storage Day 2023. Welcome to the session on building and running your analytics and SaaS applications at scale. My name is Christian Smith. I'm going to be the first person going solo on the desk today, and I'm head of the worldwide go-to-market file storage team. Customers are leveraging AWS for their SaaS and analytics applications. They're choosing AWS for a multitude of reasons for these use cases. First, because they want to centralize their data to derive insights for all their analytics-based applications. And second, ISVs seeking to deploy a SaaS application, the ability to rapidly build, run, and scale their applications to meet their customer needs. For each of these use cases, shared storage becomes a critical foundation of a successful deployment. Using shared storage allows for the disaggregation of compute from storage, allowing each to scale independently for optimal use. If you're a data scientist or a researcher or an application owner, you can easily collaborate on data sets, you can scale your application data sets without having to manage storage, and you can leverage the efficiencies built into AWS Storage so that you can optimally manage your data at scale. But the real goal here is to deliver faster time to insights and faster time to customer value. To do this, we have to understand how most analytics and SaaS-based applications behave at the scale against their storage infrastructure needs. First, most data analytics SaaS workloads have spiky infrastructure needs, and time to insight is typically determined by the bottleneck at peak workload, which can be costly to determine and difficult to monitor or manage or predict. Second, with traditional server-based, always-on compute and storage, builders waste limited resources in idle compute and provision storage. Customers are able to leverage a decoupled compute storage capabilities where they can deliver faster time to insights and pay for only what you use. Lastly, serving the compute needs of your analytics and SaaS application requires the performance of low latency, high throughput performance so that compute is not wasting idle time, and data and developers can work with data in easy formats for collaboration and access. And when we talk to researchers, application owners, data scientists, deploying on AWS, they often tell us they want the following for their infrastructure storage needs, which is simple to configure and set up. Look, I don't want to be a storage expert. Easy to scale across capacity and performance without needing to know the performance of my application, and adaptable across different compute use cases, such as EC2, EKS, ECS, Fargate, container serverless, and cost effective. As the data grows, do I really have to be concerned about cost? This is why customers have been using Amazon Elastic File System, or EFS, for their shared storage needs when they're deploying their SaaS and analytics applications. EFS is a cloud-native file system built from the ground up to deliver virtually bottomless file storage to customers tell us just works, where I don't need to be a storage expert to manage my file data at any scale. So Amazon Elastic File Service, or EFS, is a serverless, fully elastic, designed for cloud-native workflows. It's highly available, durable, and secure. It's fully elastic in performance and capacity. No need to frequently tune and monitor over time. And really, it's accessible from all forms of AWS compute containers and serverless functions. And with pay-as-you-go storage with automatic cost optimizations across hot and cold tiers, it is cost optimized for you. Let's take a look at how Amazon EFS impacted one of our life sciences customers. Johnson & Johnson built a data science platform to analyze genomic sequencer data, whole genome studies, medical device data, and immunology studies. They've adopted a modern data analytics approach, leveraging Domino Data Lab on Amazon EKS, and needed a modern storage solution to match. With Amazon EFS, they were able to see faster time to insights with access to new data sets, reducing analysis time by 35%. And they cut their cost by 37% using EFS Lifecycle Management and Amazon EFS One Zone storage classes. Let's take a look at another customer, Atlassian. By moving to the cloud, Atlassian was able to efficiently grow their Jira Data Center application. They can rapidly scale their Jira Data Center application on demand using Amazon EFS and auto-scaling. They increased their agility where they can now add 10,000 customers on demand versus taking weeks, if not months, to plan for it because of the complexity. Using AWS, Atlassian has everything in place to support their traffic needs immediately and in the future. Atlassian is better supporting its customers also by utilizing the built-in disaster recovery and high availability characteristics of AWS. So what does this mean? What does Amazon EFS mean for your SaaS and application needs? So let's go into this. Customers have always leveraged EFS as a fully elastic for capacity since it was created 7 years ago, where you only pay for what you use and you can scale up and scale down. Today we will talk about EFS as meeting customers' needs with its enhancements to a fully elastic performance by raising the bar in throughput, IOPS, and delivering lower latency. Let's start with talking about EFS throughput modes today. Today, when we talk about EFS throughput modes, there are 3 options to choose from when provisioning a file system. First is bursting throughput, the default mode, where throughput scales as the amount of data grows. It's 50 megabytes per second of throughput per terabyte of data with the ability to burst up to 100 megabytes per second per terabyte for short periods. This is recommended for the majority of workloads deployed where a simple standard file system is needed. Provision throughput allows you to set the throughput of the file system independent of the capacity of the file system. Provision throughput is recommended when applications have consistent ingest or egress needs beyond the size of the file system. Provision throughput is often used when migrating data to AWS or using applications in like IoT, where there's just a constant stream of ingest data and the data sizes are relatively small. Lastly, elastic throughput does not set a bandwidth limit and has no capacity constraints. Instead, it scales throughput to the needs of the application and is ideal for workloads that are spiky or unpredictable, such as at-scale analytics and SaaS-based applications. Let's talk about scaling analytics and SaaS applications because, performance planning it's hard. It's actually really hard to do. If you're actively managing your storage solution, you typically provision the required amount of throughput that your application may need. However, as you can see here, there's a catch. In most cases, you don't know your application's performance requirements. So if you have a workload or unpredictable traffic that's difficult to forecast, you may under-provision throughput, resulting in your workload being throttled or impacting application availability and end-user experience. Alternatively, if you have a spiky workload, you might go the other way and over-provision to guarantee application availability. But then you end up paying for the long periods of time where your application does not use throughput. Finally, in either case, you have the operational burden of constantly monitoring and managing the infrastructure and throughput needs to determine what is the best option for you. This is why at reInvent last year, we introduced EFS Elastic Throughput, a throughput mode that automatically scales performance to the need of the application requirements with up to 10 gigabytes per second of read and 3 gigabytes per second of write throughput per file system. With Elastic Throughput, EFS now also delivers optimal throughput performance that doesn't require the need for advanced provisioning or performance planning. The automatic throughput modes benefits the spiky workloads that on average have low throughput needs but can experience unpredictable performance peaks that are often difficult to forecast. For example, like machine learning, analytics, DevOps applications, media processing are just a few of the examples where there's long periods of lulls followed by spikes and peaks as users start accessing data. And speaking of performance, we continue to raise the bar on EFS fully elastic performance experience. Let's just talk about the history and progression here over the last 2 years. At reInvent 2022, we reduced the latency by 2x, where customers running things like financial risk simulation workloads just saw their applications running and finishing faster. In April of this year, we increased the throughput by 3x, going to 10 gigabytes per second of reads and 3 gigabytes per second of writes, allowing streaming workloads like transcoding of media files to process more quickly. And on 8.3, we announced a 3.5x increase in IOPS, with file systems now supporting up to 55K read IOPS and 25K write IOPS. Amazon now supports up to 55,000 read IOPS per file system, a 1.6 increase, and up to 25,000 write IOPS per file system, a 3.6x increase. I know I just said 3.5, that was in my mind. With these enhancements, you can now easily run more IOPS workloads on EFS, such as machine learning research with Kubeflow, Monte Carlo simulation with IBM Symphony, and big data processing with Domino Data Lab, which we heard from with Johnson & Johnson, and accelerate your Hadoop and Spark workloads. These increased IOP limits are immediately available to all Amazon EFS general purpose file systems using the elastic throughput mode, provision throughput mode, or in all AWS regions where EFS is supported. Okay, let's shift gear a little bit. Let's talk about cost optimization as your data scales with your SaaS and analytics application. First, let's just start out. EFS is cost optimized. EFS provides you 4 storage classes, each with different price and performance characteristics, along with the capabilities to tier hot data to cold tiers to lower the overall effective price of your SaaS and analytics application storage footprint. These tiers include EFS Standard Infrequent Access, EFS One Zone, and EFS One Zone Infrequent Access. By deploying capabilities like tiering to infrequent access, you can save up to 73% over EFS Standard alone. By leveraging one zone storage classes, you can cut costs by up to 47%, where applications do not need 3 AZ availability. And by deploying these things in combination, like lifecycle management and one zone, you can reduce costs by up to 92%. Let's go a little bit deeper in how these cost optimizations work. Let's start with Amazon Lifecycle Management. Lifecycle Management takes any files that aren't accessed per the lifecycle policy of 1, 7, 14, 30, 60, 90 days, and automatically moves that data from EFS Standard to EFS One Zone into their corresponding infrequent access storage classes without you having to do anything. The data remains in the file system and is accessible to end user and applications, but it is stored as a much lower cost point. So having both these capabilities, the IA storage classes and lifecycle management, you're eliminating the need to manually manage your data and optimize for cost over time. The follow-on to that is EFS Intelligent Tiering. EFS Intelligent Tiering makes it easy for you to optimize costs for shared file storage, even when the access patterns change or are unpredictable. EFS Intelligent Tiering delivers automatic savings for workloads with changing access patterns by placing your file data in the appropriate storage class at the right time based on file access patterns. So when that data set that has been sitting cold for months suddenly becomes hot again, it gets transitioned automatically to EFS standards. Examples include customers that are running large financial models or backtesting, and the data has been sitting dormant for months. With EFS Intelligent Tiering after first access, that data will be accessed through EFS Standard, latency and throughput performance without having to manually promote that data back into that tier. EFS Intelligent Tiering is designed to help you achieve the right price and performance blend for your application file data needs. So let's wrap up the TCO conversation. So in summary, you can significantly lower your TCO by using Amazon EFS. There's no minimum commitments or fees. You only pay for what you use, and it is completely infrastructure free. No need to manage servers or configure servers or stand up servers. You don't need to provision storage ahead of time, and you can scale elastically and instantly up to tens of petabytes of capacity. It is optimized to be consumed by any AWS compute model at scale. Multi-AZ architectures of EFS standard classes enables file use with compute in any AZ without worrying about any cross-AZ charges. EFS Intelligent Tiering supports automatic lifecycle management to lower storage cost tiers without requiring any changes to workloads and applications. If you do a total cost of ownership analysis comparing this to running your own file system on your own storage infrastructure, what you'll find is that EFS is 90% more cost effective than doing it yourself. EFS is AWS's serverless elastic file storage for builders, application owners, data scientists, researchers that deliver the just work solution for developing cloud-native apps and workflows on AWS. And the Amazon EFS team continues to raise the bar on performance, throughput, and lowering latency and increasing simplicity to make sure you don't have to be a storage expert to use EFS. Thank you for your time today. Again, my name is Christian Smith. I give this presentation one big hat. Please now stay tuned to hear how to deliver performance at scale with S3.